Hi, welcome to All About Mechanical Engineering. In this video, we will study the application of steady flow energy equation to a condenser. Now, what is the basic function of a condenser? It is used to dissipate heat of the flowing fluid. So, here there is transfer of heat from the system to the surrounding. As per the sign conventions, whenever the heat is transferred from the system to the surrounding, we take it negative. So here Q is negative and condenser does not consume any work, nor does it produce. So W is 0, neither positive nor negative, because it is neither producing nor consuming. So as per general form of our steady flow energy equation, general steady flow energy equation is given by Q minus W is equals to m kgs of mass half V2 square minus V1 square, that is change in kinetic energy, plus G into Z2 minus Z1, that is change in potential energy, plus H2 minus H1, that is change in enthalpy. So here, putting the values, if I put Q negative, it becomes minus Q minus 0 is equals to m into bracket half V2 square minus V1 square plus G in terms Z2 minus Z1 plus H2 minus H1. Here this becomes 0, so I can write it as minus Q is equals to m into bracket half V2 square minus V1 square plus G into Z2 minus Z1 plus H2 minus H1. Now, as compared to the change in enthalpy of this system during the process, these two terms are negligible. So if in the numerical, if these values are given to you, you don't have to neglect, you have to consider these two values and you have to substitute the given values. But in general case, the values which are given for these two terms are very much high as compared to the values of these two terms. That's why in general I can write neglecting changes in kinetic energy and potential energy, we have minus Q is equals to m into bracket H2 minus H1. Now multiplying by minus 1 on both sides, we get Q is equals to m into bracket H1 minus H2 for m kgs of mass. For unit mass, I can say Q is equals to H1 minus H2. Now what does this mean? As seen in our previous video, for steam generator or boiler, we had Q is equals to H2 minus H1 for unit mass basis. Now for condenser, we are getting Q is equals to H1 minus H2. Now understand the difference. In a condenser, heat is being rejected, so the enthalpy at inlet was more and outlet we are having less. So here this is the equation for condenser because heat is being rejected. Here for a boiler heat is being added, so enthalpy has been increased. So changes in enthalpy are because of supply of heat. When you add heat, you supply heat, the enthalpy at the outlet will be more than at the inlet. Whereas when you reject heat, when you remove heat from the system, then enthalpy at outlet will be less. Now it has to be understood that here Q is equals to H1 minus H2. If this is taken as positive, here Q we are already putting it as negative. So here this is being rejected. So Q is equals to H1 minus H2 is the correct term, because I have already considered negative here because it is being rejected. Hope you have understood this video and enjoyed it. Please like and subscribe our channel and stay connected with us. Thank you for watching this video.